Hello and welcome back to the development of the Feersum scheme compiler. So in today's stream I want to try and look at implementing quote expressions. So that's where you embed a literal inside your program so you can write out lists and things like that without having to build them up bit by bit. So as per usual, let's start off by going over what went on in the last stream. So in the last stream, we added this new library, which is basically our kind of core library where all of our core types are. And in the stream, we went through and implemented this one Lisp built-in. So the idea behind this is that we can have one C# library which has methods in it which we mark up with this attribute, and then we can call those from our Lisp programs. And we did a bit of reflection to find these, and then refactored some of the compiler so that we can correctly emit calls to these built-ins. So since the last stream, I've actually gone through and implemented some small parts of the actual scheme standard library. So we've now got this subset of the vector implementation. So vectors in scheme are lists which, well, they're kind of like contiguous arrays, and in our compiler, in our language implementation, we are implementing them as actual object arrays. So the actual like vector constructor, for example, we actually already in our calling convention box everything up into an array of objects, so we just return it straight away. But we've got things like vector length and stuff which unbox things and then box things back up again. And we've got a set of list methods as well. So lists are the other main data type in scheme, and well, I'd say they are the main data type in scheme. So previously we had in our built-ins, we built a type called a cons pair, which has two fields, a car and a coulda, and we went through and use that when you call a method, and we have like a rest parameter and things like that. But there was no easy way to actually make a list in our language. But with this, there's now an implementation, so you can use cons to create cons pairs directly, and lists to create a list from a set of arguments. So, and there's just a few other things that go along with it. And putting that all together means that we can now actually run a new piece of code that we haven't been able to run before. So I'm just going to go and copy that across first, because we don't have it in our spec folder yet, but we can now run this, which is an implementation of a kind of algorithm called a prime sieve. So the way this algorithm works is that you give it a number, which is the limit that it will look up to, and we have this pair of functions, mark multiples and sieve. And so effectively what it does is, for a specific number, in this case we start off with 2, we basically have a vector which is all the numbers that we're trying to find prime numbers in. So this, if we start off with 10,000, this will be an array of 10,000 false booleans. And so what we do is the sieve function recursively goes through and marks everything that is a multiple of the so it recursively calls mark multiples, and then effectively what you do is like you mark everything that's a multiple of 2, and then everything, basically you just keep on increasing that number. And so at the end, you'll end up with an array that tells you everything that isn't a prime. And so we just walk through that array at the end, and that's our primes. So we can now run this. So I'm going to run the test task. It's going to tell me that it's going to fail because we don't have any snapshot yet for this. But the thing about this is that the actual return value here and the fact that we can compile it isn't necessarily enough to really do a proper job of testing. If we have a look at the test output here, I mean, we've got 2 failures there, one for the parser and one for the run. We can see that the majority of the test output for this, I know that this one comes from the Erasmus or whatever, however it's pronounced, some Greek person from history. We know that this one's the output of that program because who else builds such a huge list of numbers, all of which are prime? And it'd be really nice if we could check the output. So we've got lots of other tests which are producing output as well, and it'd be nice if we could guarantee when we're running our spec tests, not only that they do compile and run and return the same value they used to, but they also produce the same output. So that's where we're going to begin before we start tackling anything more complex. And this is going to come in useful when we work with implementing quotation expressions, because being able to build up a list or something like that and then display it and assert that the right list was built will be very useful. We don't really, effectively the only thing we can check at the moment in our spec tests is the single return value, which means that it's only the last thing in the program. And if it's anything that's more complex than just an integer, then what we end up doing is just returning true or false. Effectively, we return an exit status that reflects the Boolean value of that if it's not an integer. So like returning a string or something like that will just return a fixed exit status and not anything based on the string. So you could have messed it up and you wouldn't really get a breaking test. So let's start out by going to the spec tests. Well, actually, let's start out by creating a snapshot for that test. So hopefully we should end up with a snapshot for the parse and a snapshot for the spec. And it says that it exited with 0, so everything, the program runs fine and doesn't crash, which is good. But we could do better. So in the spec tests, we list our specs, and then so this test here, spec test compile and run, is the one that's responsible for taking the specific spec which you found. So in this case, it could be like list.scheme or whatever, compiling an executable from it by calling compile file with the input path and the output path, and then running it. And we check that if it should fail, we get a compilation error, and if it shouldn't fail, we don't get a compilation error. And then we run it, and then call exit code should match snapshot. What would be really nice would be if we could capture the output of this. So what I'm going to do is I'm going to extract a method first, I think, for run, which is going to take run example. It's going to take an exe path and it's going to do, what's it going to return? I think we'll leave that for a let r, just a generic result equals run example exe path. That's all we need, and then we can do a snapshot. So we can do r dot should match child snapshot s, and then this is going to be, and then we can do p dot exit code. So now the tests should still pass, but what we'd like to do is put more information into what we're doing here. So the way we do that is by, instead of doing process.start, we have to do let p equals process. So we create a new process and then we set a few things on it. So we need to what do we do? Do we pass them in the constructor? I can't remember. We need to effectively renew up a process and then call process dot start run. It's complaining because that isn't really starts or reuses the process resource that is specified at the start info property. Okay. What are you complaining about? The result of this expression is the type bool. And this is to indicate the resources may be owned by the generated value. Okay. What do we want to do here? Oh, we need to say, like, we could do an assert here. P dot start info process start info. So we create a new one of these structures. And I think we want to say .NET and XPath. Does this still work? There's some way you can say that we should redirect the standard input and standard output and stuff. Right, so that's still working. So p.start info what is it? You shall execute. I think that wants to be redirect standard input, standard output, and standard error. So I think we want to set those all to true, and then we want to, then we'll be able to capture it later. So we've got the file name. So I think we can pass the exe path like this: program info.arguments and exe path, and then I think we can also say that we don't want to shell execute. That could end up causing us problems, I think, depending on whether or not you've got spaces in your path and stuff. It might end up trying to split the exe path out into various different things. We've got that. Then we want to say redirect standard input true, and we'll do the same for standard output and standard error. Do you want to redirect standard input? We'll consider it. So what else do we? There's I think there's then a set of callbacks. P dot standard input, standard output. What is a P dot standard output? It's a stream reader. Okay. Can I read to end async? Read to end. It's just going to give us a string. Okay, so I'm going to see whether or not we can just read the standard input and standard output at the end after we've done everything else, and just return a tuple with standard output, standard error, and the exit code. This could end up going horrifically wrong because we might end up with, it might end up being that once you've closed a process, you can't read from its standard output and standard error. But I don't launch processes often enough in .NET to know. Stuff is happening. Got some failures, but why did they fail? Item 1, item 2, item 3. Right. I think we could probably do better than that. We could probably, yeah, we can probably give those names. So let's see, output equals, we'll just create a simple record for this, error equals, and then exit equals, and we'll create a type test result execution result. It is a output of string, an error of string, and an exit of int. That is because it's like that. And we'd better make the opening and closing tags match. Right, so now what happens? We still got the same test failures, but hopefully we get nicer output. Okay. We've got a massive list of prime numbers. We've got new lines and stuff correct. I don't know whether or not we're going to want to normalize these new lines at some point if we want to be able to support running on Windows and things, but for the time being we'll call that a day. We'll say that's done. So I'm going to update those snapshots and check off that to do. The other advantage of this is that we don't get any random stuff in our test execution results anymore. In fact, inspect output, inspect tests, spec tests. Now use read the standard output and error streams from the and track it in the snapshot. Good. So with that done, that means that if we write tests that produce things like a list and then call display on that list, we'll be able to check the output of those. So with that in place, let's go on to the main body of the work I want to do. So what we'll be able to do is recognize quoted expressions. So let's go and add a new file for quotations. Quotes. So a simple quoted expression can actually be something like that, where the expression is what's called a self-evaluating expression, which is something that would be itself. Like you could quote a string, I think. Is that even how you do strings? Yep. Or you could quote a list. So we'll quote null, or we'll quote 1, 2, 3. And that each one of those would evaluate to the inner thing. So let's call display a few times on each one of these. So this is going to fail in a few different ways. The first one is the fact that we don't actually recognize those. We don't recognize these quotes. So if I go to a terminal and trying to actually run the compiler against that, we will get some kind of parse error for unexpected character. I expect quotes, but we'll see. Yeah, it's got unexpected character, and then we've ended up with missing closing stuff because we've skipped things in the wrong place. We've not tracked those forms correctly. So we need to start out with a change to the parser. So let's go to the syntax and add a quoted expression. So we probably want this to be we'll do it, well, yeah, we'll do it right here. So let's parse quoted. It's going to say, well, we don't want to expect it, but we want to effectively skip char. So if we get a quote, we then return the parse form. Parse form. I'm slightly skeptical here because I noticed down here that parse form has white space, and I don't know in the spec whether or not quote is supposed to handle white space or not. And I can't find quotations in here. So let's go have a look. Looking at the syntax of the language, it is identifiers, other notations is used to indicate literal data, partly constant. So we're not going to support this second form of quotation yet. So a quote of a datum is yeah, it's telling you about self-evaluating stuff as well, but I don't think it's saying that there can be any white space between the two. The two notations, but there is actually like a grammar somewhere. So references, no. Formal syntax. So in here it says exactly what a quoted expression and all the rest of that is. It's unreal. Subsequent digit hex identifier, string boolean, comment. Yeah, comments were awkward to parse. External representation. Derived expressions. It's not a derived expression, I don't believe. An expression is either a literal, which is a quotation. Where is quotation? Quotations. Quasi-quotations? No, we just want plain quotations. Not libraries. I've missed it somewhere. Formals. Compound. So datums are actually the things that read expressions produce. So this is the whole like programs as data thing. Yeah, it is just a quote followed by datum, or it is this kind of expression. So we can handle this kind of quotation first, but it'd be nice to handle both forms. I think we can just, for the time being, ignore the fact that we're going to have white space, or we have some kind of like datum non-terminal. So an expression is what we're calling an atom, which is strings and all the rest of those kind of literals, or what we're calling an application, which is a procedure call, or it's a derived expression, which we're also considering an application, a macro use or a macro block or an include. So I think a form should be a datum between white space, and then we can say let a datum be an application or an atom, and we need to do that after application, which means we need to do that quoted after that, and then we can say parse quoted is a datum, and then we will make it into a spanned node and quoted spelled correctly, roughly correctly, yeah, like that. And so then we need a type up here for quoted, which is going to be quoted of AST node kind of our kind. Later on we might put a quote kind in there as well, so we know whether we're in a quasi-quote or a unquoting and things like that. Quoted Y. Expecting an AST node, but given an AST node kind. Ah, so it just needs to be T. Okay. That makes sense. So now we should be able to at least parse this. So let's run the test task and see what happens. We should end up with a parse result for this, if everything goes well. Going to go and make the test output a little bit less verbose. That's in the tasks JSON. .NET test. Yeah, we don't really need it to be that verbose. I bet if we get rid of that, we're going to see that the test doesn't give you that nice listing where it tells you what it's running. Yeah, it just gives you the output. Okay. Snapshot does not exist. Fair enough. So we want to find a slightly less verbose. So what are the verbosity levels? Let's see. .NET help. Roll forwards, fix version. No, none of that stuff. Diagnostics, info. No. Let's do .NET test. Blame, crash, runtime, framework. Verbosity. Come on, you gotta be in here somewhere. Settings, logger. Quiet, minimal, normal, or detailed. So apparently normal is a lot. So let's do v equals m. And see what happens. Just want to be able to see the test run without seeing a bunch of MS build output. That's a lot nicer. Well, is it though? Because we're still not seeing. How do we get it to show all the tests that run? XUnit show all tests run. All tests. I think there's actually a logger parameter or something. Which this is turning into a sidetrack. .NET test list tests that pass. Is there a way to show the tests that are running in the console? Yes, you can do .NET test -v equals normal. Yeah, but okay. So the recommendation on Stack Overflow is set v equals n, but then set no build as well. And then we can depend on the build task. So the build task will build it, and then we will run it. So you don't see all of the verbose output from the build, but you do see main. It's better. I think we'll settle for better. Make tests less shouty. That's probably enough explanation. In our back to syntax then. So we're doing our quoted expression. I think that should be enough to actually produce quotations. What we did see though is that it doesn't compile. Because we're going to get some build errors. But we can have a look at the parse output. So we're now getting display and then an error. And an error and then an error. I'm not seeing any quotes. Ident point dummy. Ah, yes, because we haven't actually said. So a quoted expression is here, but we don't actually use it anywhere. So what we want to do is a form is a datum or a quoted. And I guess datum should be parse datum, following the naming scheme from anywhere else. Parse datum. Now what do we get when we update our snapshots? Did not log an error. Fair enough. We get an ident and a quoted number, and we've got span information and all the rest of that kind of stuff. But our stream name, like, we've still got the full path in here, so we need to go and fix that up, which is in the in syntax utils. We have this sanitize method that basically anything that has an inner expression, we need to have a way of sanitizing it effectively to remove any position information. So a sequence and a form and a quoted, we're going to say, is just going to be sanitize the quoted thing and then quote it again. I think that should do the job. Snapshot update. Once we get this parsing cleanly, then we can work on actually binding these expressions. Point number quoted dummy, right, that's good. I was wondering actually as well about Do we want... We've lost the line and column information. That might be nice to keep in. So while we're in here, sanitize node calls sanitize. Sanitize says take the node kind, sanitize the kind, and set the location to dummy location. Instead, we can say, how about we say node.location with, what is node.location? Is it something we can syntax factory dummy location? How about sanitize location? Maybe then. Because we're kind of losing information there, and we'd rather not, because if we end up messing up at some point and producing the wrong text locations or something, it'd be nice to get unit test values for that. Let private sanitize, well, let's just make it public. Sanitize location lock. We will say, actually it's just going to be a function, because then we can say text location dot point, which is going to be some kind of sanitization thing. Sanitize point to and then sanitize span as well. Spans have a start and an end, and we need to sanitize point on both of them, which doesn't exist yet. Span start and end point. So how are we going to sanitize a point? P is going to be P dot. This is an R point, is it? This comes from fparsec. It's a position. Well, how about we import fparsec's position? P dot stream name. Can we just set it? Nope. P dot. Can I say P with stream? May only use with record types. To build object types, use new type with. Okay. New position. It is sealed. Let's just build up a brand new position. So position takes a name, dummy, takes an index, it takes a line, takes a column. column. Okay. That should do the job. The reason why we need all this sanitization logic is it's fine for me to run this unit test on my laptop otherwise, and the tests will pass, but they will fail on the build server because do I need to open Syntax Factory? Apparently I don't need to open Syntax Factory, so we'll just leave it like that. Is it going to build? Yeah, looks like it. So if I run the tests now, what's the situation? I bet they're all going to fail because I've not updated the snapshots properly. Yeah. Update the snapshots then. Still got one failure, I think. 2 failures. What are the 2 failures? The match cases were incomplete. Okay. That's because we haven't handled quoted forms yet. And that is one test. Let's pass expected. I see. Do I see? What is that? Is that actually a syntax failure or what? It says it's to do with this. Is it? Do we have a? It's a syntax test, not a spec test. Maybe I do see. Okay. Sorry. I think this is because we are using that sanitize method in another place. Yeah, here to kind of make some nodes. So node yeah. So I think maybe we need a new sanitize method. So we've got this sanitize method, which does the main sanitize stuff. I think we might need like a point rewriter and pass that in. dummy point maybe. So like make dummy which takes a position and just returns dummy location. And then we can have sanitize take a, we'll make another method, sanitize with, which takes a point rewriter and a node, and sanitize with is going to say sanitize with use dummy points, use dummy points node. So we sanitize the node with the dummy point. We can all have like also have and sanitize with position node, which is then going to go sanitize with sanitize point. We could say that's like normalized paths or something. Node, no, node, and then that needs to be sanitize location with the point rewriter. With which we're just gonna pass through like that, and sanitize location takes the point rewriter and sanitize kind is going to call, is going to have a rewriter as well. And then we can call sanitize with rewriter. What is wrong with normalized paths? Given a position to text location. Dummy location. So this wants to go back to calling normalized paths, I think. And then we can say just use the rewriter. And no, instead of normalized paths, we'll use sanitize location. Is that going to work? rewriter is a position to text location, but why? Because normalize up here, it needs to be a text location. We can just make it and a location L and let F# work out the types. Now we should get only one failure for the fact that we can't actually do quotations. We do. We get one failure. Let's go review all of the quotes. So we'll do just one commit that's got all of these snapshot updates in then. We need to actually use the new sanitize with position in the spec tests. Just undid all of that. So sanitize. Sanitize with position is not defined. Kind of probably should be. Unless... yeah, it builds. It's just lies. Compile and run. Yeah, now we should be able to update the snapshots and see a whole bunch of changes. Ready for it? Boom. So I'm just going to add all of these changes in one big blob. Three dot. Okay, I think that's right. I've got the same kind of pattern all around these files. And we've gone from using points to using spans, but I think that should be correct. And let's commit that as actually let's just check the paths. Yeah. Preserve line and col in sanitize or spec tests. Stop stripping out too much information from the spec tests and pass results. Okay. Back to the binder now. We've now got our quoted expressions. They'll be appearing somewhere in this binder. So when we call bind in context, we need to handle it. So we haven't got all of the AST node kinds in here anymore because we just added the quoted one. So if it is a quoted expression, we need to bind quoted, I suppose. Some form or the other. That's not how you spell quoted. Well, it's not how you capitalize quoted anyway. Quoted, quote. What did I call it? It is quoted. I think someone's autocomplete information is slightly out of date. So yeah, we want a new kind of binder. Quoted form or what do we want to do here? I think the first thing we want to do is check what the inner is. So there's a kind of, the obvious one is if the inner thing is something that is a literal, we can just return it straight away. In quoted AST node kind dot. So if it's a boolean or a character or any of these other things, we can just any of them that are actually literals, we can just return the literal. So let's see, we've got booleans or what else? Numbers. That needs to be like anything that's a boolean, anything that's a number, anything that's a string. Actually, well, I suppose we want characters. This is starting to look like going the other way and choosing everything that we don't want to just return the inner one would be the easiest one. So the things that quoting changes are sequences, forms, and idents, I think. And everything else, we just want to return, we just want to bind it as per normal. Yep. Bind. In context, we need to take a context. That's what we need to do. Take that context from there. Good. And we can, yeah, we can do a bound error, can't we here? Ah, no, it's, we need to fix it, so let's just leave that. So if we run the tests, what happens? what we could do is we could return an error expression without emitting a diagnostic, which is a cunning way to get the compiler to fail further down the chain. So we will refuse to emit the bound tree because we'll find the errors in it when we try and lower it. But that's nicer than just throwing the exception. Can't quote yet. Because it should be able to continue to bind for the rest of the thing, and we should then just see whether or not we get any diagnostics for binding any of the other bits of the program. If we get no diagnostics for that, then we'll start emitting a bound quoted expression, I suppose. Do we get any ones? Yes, can't lower. Good. So for this bound quoted, I think we want to say bound quoted, bound expression dot quoted. Do we just want to pass the syntax node right down? I don't think there's any reason at this stage I mean, whatever is in that AST node kind, we do need to support the ability to quote them. So yeah, bound expression dot quoted. So we just pass the syntax node in, and we'll have the lower pass work with that. Quoted. Come on. Go to definition, and then we'll say you could have a quoted expression of AST node. And then in the interpreter, we'll need to handle this. Will we? Nah, I mean, don't care about the interpreter anymore. Compiler, we need to handle this. So somewhere in here we've got a massive switch where we go over all of the different types. Here we are. We've got the error, the sequence points, ifs, lambdas. Let's do this right at the end. Bound expression quoted if we've got something that's quoted, we'll do something. We'll do the traditional load null. I mean, it might be right. You never know. If you quoted null, then that's 100% test passing. So now we should see the test fail because we don't have a snapshot, because it should now be able to compile it and run it. And it should just display a few nulls for all of our quoted expressions. Fingers crossed. Is that a snapshot not found exception? It is a snapshot not found exception. But how do we emit a quoted? I think we're going to have to do an emit quoted. We'll pass our emit context down and the quoted expression. And then emit quoted is going to take the context and the quoted expression. Well, it can just be a function for the time being. It's going to take AST node kind dot, and then we'll just go through all the different ones. Fail with unsupported quotation kind. So for some of our literals then, what do we have? We've got error, sequence, null, number, string, character. These are all going to want to be brought into their own methods. So it's going to be like emit null, emit number, emit string, and then we can call it from the quoted place as well as the unquoted place for the self-evaluating things. Then sequences we need to turn into lists. Applications we also need to turn into lists. Yeah. So let's start with all the different kinds of AST node kind. Number. I'm just going to go and steal them all from the definition. And quote them all out for the time being. So an ident. An ident. What would a quoted identifier be represented as? I don't know. So we can leave that as an unsupported quotation kind. We'll move that right down to the bottom. Error. If we get an error, we should or what happens if we get an error right at the top? What do we do there? Fail with. Okay, because emit expression, does it produce anything? It doesn't. It produces a unit, so there's no way to produce a diagnostic. Fail with error in quoted expression. I actually spelled expression without spelling expression. No. Something's wrong with the world. So, number. If it is a number, emit number. In the current context, n. Let's go make emit number. like, a lot of these ones don't actually, well, no, because they need the type system to be able to do boxing and stuff. I'm wondering about breaking these into, I'm thinking null and string, boolean, character. So all of these are the kind of like core literals. They could be moved into their own like type. So we could have like a bound expression dot literal and then literal with the different kinds. That's what I'm going to have. So in, we have, what did I just say? Type bound literal. It is boolean, character, number, string. Load, store, if, lambda, null. Sequence if, right, and then we say it is a literal of bound literal. This is going to be a bit of a change, isn't it? So this is going to be bound expression dot literal yeah, close enough. Literal dot number. And I should have done multi-cursors there. I'll do it now. Bound expression dot literal dot whatever. Character, number, string. Because it's bound literal, isn't it? Bound literal. Is that all the red? That was a surprisingly simple refactor. Then these ones here, I can just do a single if it is a literal emit literal what are we gaining ourselves here? Well, bound literal. could then do emit literal in this context. Literal. But ideally, match no quoted dot kind. Really, we're still got to do the whole switch. Yeah. We've still got to do the switch for the strings and all the rest of that kind of stuff, but yeah, I guess at least we're not spewing a whole load of functions all over the place. So let's do that. Wonder what? Yeah. So if it's a string, we'll do emit literal, and I'm just going to copy and paste this because we're living in the future and computers can do all this work for us. Str, yes. Boolean, yeah, character. Yeah. What is a quoted dot? Let's go find out. So if I do a quote of some number, I get the value. If I do a quote of a dot, it's a quoted identifier. Okay. But dot on its own is an unbound variable. Oh, define dot. Ill-formed syntax. Yeah, well, I thought that. Can't you do something like that? Yeah, so it is technically an identifier, but it's not one that you can use. But we can move it down here and use it as an identifier. Nah, technically, but not a useful one. What happens? Yeah, what happens if you quote something that's quoted? Ah, okay, right. You get it as if it was the desugared list form. So quoted Q fail with should be quoted, so we know what to do in the future. Then forms and sequences, how do we emit those? Well, we'll do sequences first because sequences should be the simpler of the two. So if we get a sequence, we'll do emit quoted sequence. quote sequence. The right number of letters in there. So let's define a local method. Let quote sequence, some sequence be is that going to release type check? Quote sequence, quote sequence. Which one of these is spelled correctly? That was not the right one. So to quote a sequence, we need to basically make a list. So our sequence is going to be a linked list, and we need to turn that into the same kind of thing in we need to take so if we've got a list here, which is going to be a list of it's going to be a list of AST nodes. We need to turn that into an actual list of cons pairs. So for every node in that list, we need to make a cons pair. So what we'll do is we'll start off by allocating a local equals context dot, what's it called? Debug documents? No. Locals? No. Temp? Create temp or something? Make temp. Close enough. So you make a temporary in the current init context, and the type is going to be, is there a make temp object? If there is, let's just do context dot assembly main module type system object. So this is going to be the return value of our function. So what we'll do is we'll first store our null into that local lock, and then we'll do something. So we need to build. We'll and build up the list, and then return the result, which we're just going to do by loading this value back again. Don't need to, like, it's not returning it from a function, but we're just basically putting it back on the top of the stack. So we'll have some loop in here which will do a sequence of instructions to recreate that list. So return, we need to do load lock here. This should now run. So I'm going to try using this interactively, and let's see whether or not we can do some quoted expressions. We should expect them to. Bound expression does not define the field constructor or member null. Well, that's upsetting. Yes, so that wants to be bound expression literal bound literal null. And we need to do that in the interpreter as well. So the interpreter says, so bound expression literal bound literal null. So we just simply need to copy that and then just paste it down here, and it's just going to magically work. No, it's not, because we need some brackets. Where's the character? There's a character literal somewhere as well. I think we're just not emitting characters here. Fair enough. Right now, does it work now? Pattern discriminator quoted is not defined. No problems in the workspace. Good. Don't want problems in the workspace. So we have a REPL. At our REPL, we can do, we get a quoted literal back, and we can do a string, and we get the string back. And if we do an empty list, we get an exception. I was really hoping I was going to get unsupported quotation kind, because you are treating that as a form, not a sequence. Okay. So let's go find out what it thinks it is. So in the compiler we have unsupported quotation kind. I really shouldn't have stopped that debugger. We could have just tried it again. So a quoted empty list. What is the kind? The kind is form, and it's an empty form. Fair enough. So I think what we can do is we can special case this in here. So if it is a form, what does a form have inside it? A list. Then we just say emit literal context bound literal dot null. For a form that's got more, we can just do quote sequence. Oh, nice. Is that actually going to compile? I don't really understand how you could ever possibly quote a sequence. So I think it doesn't really matter that we're treating those two things as the same. But I should now get my null. Oh, we can check off that recognize. We are actually at least recognizing the simple form. Right, what's going on now? Can I quote that? Yes. How about hello worlds? Nope. How about 1, 2, 3? Good. So what we'll do is we want to loop through the list that is the sequence. So we do list dot iter, but we want to reverse it. But list dot to seek. So we'll say we'll take the sequence, enumerate it. Can I do sequence dot reversed? Reduce back. I think we just want to do reverse it and then iter, and for each item we will fun effectively quote it again. So which way round are the two in the constructor? I think we need to put the quoted thing on first and then let's have a look. Cons pair. So what we're trying to do here is we're trying to arrange things on the stack so that we can call a cons pair constructor. So the way this works is you have to push the leftmost thing first and then the rightmost thing. So the rightmost thing is the tail of the list, the leftmost thing is the current item. So we'll omit whatever we need to do to quote this current thing, which is going to just be emit quoted it. And then once we've emit quoted it, we can emit a load local. So we load the current value of the tail of the list. And then let's just call this Q because it's nicer. So we have the quoted tail of the list. just spell quoted right. We have the quoted tail of the list. Then we'll call the constructor. So we do that by doing a new object. Create a new object, and we have the core cons pair creator. So create a new cons pair, and then we'll store it back to the same local. So for every single thing in the list, we'll basically create a new cons pair and assign that. And this iteration is happening at compilation time. So this isn't like a loop that's going to happen. We're going to emit a block of code that will do the right sequence of things to build up your nested list. If everything inside the list is a constant, you could theoretically just emit a constant for it. But I'm not going to try and do that yet. And this approach of iteratively building them might be more applicable when we get to things like unquoting and that kind of thing, where you can kind of interpolate bits of scheme code and bits of quoted code. So let's try and run it. Here we go. I really wish there was a way that you could just get that terminal to come to focus first time. 1, 2, 3. We get out a list with 1, 2, and 3 in it. That's quite an achievement. By quite an achievement, I mean, yeah, it works, but only for numbers for the time being, because we've got some parts here that we need to deal with. So we need to deal with inner quotations, and we need to deal with wow, what's the rest of this? If I get rid of this, what does it say is not covered? Is it happy? I think it's happy. So say to do support identifier quote. So that does want to be an error when we've encountered something that isn't. There's an error inside our quotation, but the rest, the other two are to-dos. So that's one way of quoting, and then obviously the other way of quoting would be if we were to actually explicitly call quote. So quote is a special form, as well as being like you can put a quotation in there. So to support that, it should be simple as adding another special form kind to our big switch statement. But yeah, right now if I do quoted and then I don't get the number back, reference to undefined simple quoted. So what we want to do is go into the binder for bind quoted. We've got some questions. Yeah, Ruben, the special funky pipe stuff is, so in F# you can define custom operators and stuff, and the fparsec library defines a set of operators that mean things for, rather than chaining functions as you normally do in F# is for like chaining the parser combinators themselves. So in that case, like pipe and then two two arrows are effectively you're piping a parser through a function. So it produces another parser that that takes the first parser and runs a function and then produces a result based on the output of your function. There's other ones like dot and two angle brackets, which picks the left hand one, and then two angle brackets and dot, which picks the right hand one, and things like that. But they're all fparsec specific stuff, so read their documentation to find out what's going on there. And as for eval, we don't have eval yet. Well, I mean, I have a REPL, so I have like from F# there is an eval function that you can call, which compiles the code and loads the assembly in memory, but I don't have the eval function exposed to the scheme language itself yet. There's a fair amount of the like runtime library stuff that isn't supported yet. The big things that are missing after we get quotation done is macros though. So a lot of these built-ins here, which a lot of these built-ins aren't yet supported. Just looking at that says that's quoted, and it's because I've called that wrong. If I call that quote, I would have seen quote expressions are not implemented. So, but these would be nice to implement with macros, I think. So things like and or are quite easy to write as a macro, which basically expands into some nested ifs. But for the time being, for quoted, we want to do something like bind quoted, and the body is going to be, it needs to be a list. So let's do bound, it's not a literal, bound expression dot form, and then the body. That is a list of T, that's a list of T, body. Can I do it like this? I can, oh, no. Bound expression dot form. No, it's not that, it's an AS. Trying to work out what the best, that's expecting an AST node. We've got a list of AST nodes. And really, we want access to the bind quoted bind quoted. It's just going to say we want this to appear as a quoted sequence. So what we can do is create an AST node sequence and pass that in, I think. So we need to do AST node kind dot sequence body. So we create a sequence. Yeah, and then we make a node out of it. So we can do that by just saying kind equals sequence and position. Is it position or location equals node dot location? So we fabricate some AST nodes. So we basically just remove the quote bit off the front. What do we got here? Form. Okay, it's called form, not node. Form dot It's just location. Okay. We then do bind quoted. Is that just going to work? We need to pass it the context. Fabricate an AST node. Quote that. Right, so that means that now I should be able to use the long form, the non-sugared version of quote, and have that work as well. Which I'm gonna claim satisfies the last of the main to-do items. So let's just try that out. So if I do quote, I get not quite right. Ooh, let's see what is actually right. If I do quote 1, 2, 3, I get 1, 2, 3. If I do quote, I get ill-formed syntax. Okay, so it's not even as complex as I just made it. If I do quoted, what we need to do is this needs to be, we need to match body. If body is a single thing, item, don't know whether or not we want, yeah, let's get padding. If it is a single item, we'll do bind quoted the item. If it's what's quoted? Quote. What's quote with nothing? Yeah. If it's anything else, we'll do ill-formed. Now, what happens? Did I finish the C# library for emitting IL? Yes. So now, oh, if you mean did I finish the standard library stuff that I was doing in the last stream. So now we build a library that has a number of methods in it that are all marked up with a given attribute. We detect those at runtime in the compiler, and then we emit calls to those methods in the second assembly, rather than doing what we did before, where we had all of the IL that emitted into the user's assembly. So like if we were compiling a specific program, we just like emitted all the IL for our runtime library as well into that same assembly, which is a bit of a mess and required manually writing IL. So now, because of that, I've been able to create some parts of the library in C#. So now the cons pair, instead of it being emitted from raw IL, it exists here, which means I was able to write like a toString function that works. We've got list methods, which has all of these different things like the null built-in, the cons and the list and the pair and stuff like that, and vector built-ins as well, which are all written. So it's a lot easier to just like crank out some scheme libraries than it was before having to manually write all of the IL. And with any chance, the Roslyn compiler might actually emit better IL than I would do. But ideally, we get to a point where we can write those scheme libraries in Scheme themselves. So library support as well as macros is another big thing. Anyway, quoting. quote. Quote. Not very good at spelling the word quote today. Right, that works. And if I do quote without anything, it says ill-formed. And if I do it with one thing, it says ill-formed quote. Nice. So I think that is bind and lower quotes done. Let's just run the update snapshots task and find out where we're at in terms of code changes. So we've got our new quote example, and what we can do is we can do the same set of quoting with with the full-on quoting like this, quote, which I'm getting nice syntax highlighting for. Also, I'm editing in the diff viewer again. Is that? What else have we got? So in the binder, we've now got this new bound literal type. In the compiler, we've got changes to support the literal type and this whole emit quoted and emit literal thing going on. In the interpreter, we've got the literal support just kind of tacked on the end because the interpreter doesn't really get much love these days. Yeah, don't ever actually try and run this in the interpreter mode because it's just going to explode in your face, which would be unfortunate. Then we've got parsing support for quotations, which turned out to be quite simple. These are those parser combinator operators I was talking about earlier. So things like that means run this parser, then run this parser, but pick the second one. So we're going to end up with just this second parser. Which is the parse datum one. And then this is just going to take that. Span node is our parser combinator that's going to, well, it's our function that takes a parser and returns another parser. So we're not using the special operator here because we've got this combinator, because we want to be able to get position information into our tree. Spec now does the with position stuff. We've got the parse and we've got the output of our quotation stuff. Nice. So we can say this is pretty much quotations done. The thing that's not quite done yet is if I go back to the binder, when we bind quoted, we don't bind quoted. No. No matching symbols. When we call bind quoted, we pass idents through, but in the compiler we don't. Ooh, actually that's a good point. In the binder I think binding context is going to error if you get a dot, so we need to put a dot in here as well. Because dots are actually identifiers. But we don't handle them in the compile, so we've still got the problem here with quoting, and we've got the problem with idents. We can probably solve the quoting one for the time being. We need to be able to support quoting that identifier there, so it's only going to shove the problem further down the chain. But effectively, if you've got a quoted, we would do bind sequence, quote sequence, but paste an identifier on the front. So yeah, this would be something like quote sequence, but we take we make a new AST node which is an ident quote and location quoted.location, I guess. Doesn't really matter except for debug symbols and stuff, and paste that on the front of this. So we'll do a list of those two things. So it's going to be wonderfully indented. Q, something like that, and then send it to quote sequence. Quote, 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 1, 2, 3 should turn into quoting, or at least in this other scheme implementation, if you do quote, quote, you end up with quote, literally. Put more quotes, you just end up with more quotes. So it's actually a list though. So if I do car, I could quote, quote, 2, 3. This should pick the second quote. Oh. What did I do wrong there? Why is that not the second quote? Car. Yeah. Why was that? Quote, quote, 1, 2, 3. Oh, it's a list that contains a list. Ah, I see. And then the first item is the... Right, I get it. I don't think it's going to error if we try and chain quotes. I think. Well, I mean, it is going to throw an error because eventually we're going to end up with trying to quote this identifier that we've just fabricated here. Here it has bound expression. That's a shame. Does it really? AST node kind. Is this because we've got quoted in both bound expression and the other one, and the AST? So it builds. I think that's a spurious error. Test. What's the test up to? All test pass. Right. So I think that's about done now. So I'm going to call it a day and commit this. So anyway, thanks for watching, and I will see you next time. I hope you've enjoyed this. If you've got any more questions, then I can answer those, or if not, then I think that's it. Right, thanks.